So we are going to be talking about classes and objects. And in object-oriented programming, this is foundation information. So we did get into this a little bit in our first programming class, but we are going to spend some time on it in this class because, as I said, this is foundational information. And it is really important that you understand, how classes are created, how the members of a class, which are the fields, also called variables, how those are not only created, but how they are accessed, and how to create the class methods, how to create objects, all of that fun stuff. So we are going to start with a review of object-oriented programming terminology. So terms that you should be familiar with, hopefully you are. And if you're not, we will describe them now, and you will be experiencing what the terms are talking about throughout the rest of the semester. So a class is basically a blueprint. It's going to describe the data that you're storing. Those are going to be the members of the class. They're also called fields. They are also called variables, but it's the data you're storing. You will also indicate in a class how that data can be manipulated, and that is through the class methods. Then you will indicate what data, so which one of those members or fields can be accessed only by programs that are in the class, and what members or fields can be accessed by programs that are not part of the class. Okay, so all of that goes into creating a class. Once you have a class, and a class is just a blueprint, okay, you can actually use the class to create an object. So an object actually occupies space in memory, okay, and an object is what we use to store the fields that are in a class. Okay, and when you create a class object, you are instantiating the class. So the object is an instance of the class. So what is abstraction? When you are using classes that other people create, you can create objects without knowing the inner workings of the class. You don't need to know what the members are. Okay? If you're going to use methods, you have to know what those are. But as far as the members of the class go, you don't have to know what they are, and kind of the inner workings, how the data is manipulated, you don't need to know that either. And abstraction basically is hiding those internal details of the class from the users. So we use all sorts of methods from the C# libraries. They're part of the language. We've pretty much used them from day one. So we use console.writeLine. Console is a class, writeLine is a method. And then, in double quotes, we send the writeLine method whatever we want displayed. And magically, inside the console class and the writeLine method, it does some magic and it displays what we want on the console. Okay, so that's kind of abstraction. We are basically using the writeLine method without knowing how it's coded. Okay, so the inner workings of that method are hidden from us. Okay, and we basically deal with abstraction every day. You start your car without knowing how the engine was built or without knowing how gas flows through the engine. We use a microwave without knowing how microwaves actually heat our food. Okay? And I'm sure you guys can think of all sorts of other things that we use every day that involve abstraction. So what is data hiding? Well, data hiding and abstraction are related. Uh, Data hiding is the part of abstraction that deals with making our fields private. When we make the fields private, then any program that is using our class cannot directly access those fields. Okay? You basically have to call a get or a set method to access the fields, or maybe when you create a class object, you use a constructor that accepts parameters and you pass it data. Okay, but you don't really have direct access to that data because it is hidden. Okay, and one of the reasons for hiding data is to make the data more secure. Encapsulation is again related to data hiding and abstraction. And its main focus is on hiding the complexity of the program using access modifiers. So by using, private versus public, we can hide what is going on in the program. So obviously, if something is private, if your method is not part of the class, you cannot access the private fields. Polymorphism. So polymorphism is prevalent in object-oriented programming. It's basically using the same name for multiple things. So, for example, we can use the same name in multiple methods. We can use the same arithmetic operator. We can overload arithmetic operators so that plus equal does not really mean plus equal. It can do other things. So there's all sorts of ways that we can overload in C# and in other languages. And that is what polymorphism is referring to. So how do you create and use a class? So when you define a class, you, for right now, you are going to define the fields and the methods. We will also be defining constructors. In upcoming weeks, we will be taking a look at delegates, events, and last semester we also used properties, and later in this semester we will be using those again. So a class and its members can have different access modifiers. And we've pretty much used private and public so far. But there is another one called protective, and there is another one called internal. For right now, we're going to stick with public and private, just because you are getting used to the access modifiers. We will be using them a lot more when we get into inheritance. And then I think you are really going to have a pretty good feel for what access modifiers do. And that will be very apparent when we do inheritance in a few weeks. To create your class, you're going to use the keyword class. followed by the name of the class. So we start with an access modifier. And so the default is private. So you have public, private, and we also have static. We'll talk about static methods and classes in a few minutes. So you'll have your access modifier, keyword class, and then whatever you're going to call the class. Inside the curly braces, you're going to have your member variables. So a member is a field. It is also called a variable. Okay, all same thing. You will have an access modifier, and the default is private. But it is good practice to key in the word private. And then you'll tell it what the data type is, and then you will give it a name. Okay, and below that, you will have the methods. And this will include a constructor. If you create a parameterized constructor that accepts data that is passed to it, then you also need to create a default constructor. And a default constructor doesn't have any data passed to it. What happens if you omit a constructor? The C# compiler will create a default constructor for you. And it's the job of the constructor to basically put zeros in numeric fields, and for reference types like arrays, strings, those types of things, it puts null into those fields. Okay, so it will create a constructor for you by default, but if you do create a parameterized constructor, then you also must do a default constructor. Okay, and then you'll have your various methods. If you have private variables, then you're going to want get and set methods. And if you know how to use properties, which we did cover last semester, feel free to use the shortcut get and set methods that you can use with properties. Otherwise, you are going to kind of go long form with the get and set methods. Let's see. We've talked a little bit about private and public. So private is only accessible from within the class. Public is accessible from within the class and outside of the class. Okay, so that is the primary difference. Your methods may have a return data type. Okay, and if it doesn't have a return data type, then you can use void. Okay, so if it's not returning data, just use void. And then the parameter list needs to have a data type. And quite often, the data type is the data type of your variables, and the parameter list is the equivalent of one of the variables, and you'll see that in a few minutes. So adding fields to a class. If you are creating private fields, it is best practice to begin them with an underscore. Okay, now different companies are going to have different naming conventions. What I have seen most often used is the underscore followed by a capital letter. So that is what we are going to continue to use. Our current textbook does not use this convention, or they don't use it yet. So just be aware that, there are style differences. Is it going to cause a compile error if you don't use an underscore? No, you are not going to get a compile error. But there is a very good reason for putting the underscore in. And the primary reason for doing that is to avoid naming collisions. And when we get down to looking at the keyword this, I will show you what I'm talking about. Creating methods. So if you have private fields in your class, then you need to have get and set methods because the only methods that have direct access to those fields are the ones that are in your class. And so for a get method, that typically just returns data, okay? Because you're going to be retrieving the fields that are part of the object that called the method. And so there is no data being passed. It's just going to access those fields and return them. Same with get ID. In order to use this method, an object has to invoke it, and that object is populated with the ID first name and last name. So get ID just returns the ID portion of the object. The set methods are actually used to place values into our private fields. So you can see we've got set ID, and we're bringing that in as an integer, and we're just taking the identification and putting it into ID. And here we're bringing in a string called first, and we are putting it into first name. Here we're bringing in a string called last, and we're putting that into last name. So we are assigning values to our private fields. Constructors. So constructors are used to initialize the fields that are in your class. Okay. And remember, fields and member variables are the same thing. Okay. So when you create a class object and you use the keyword new, if you don't pass any data, it goes to a default constructor. And the numbers get set to 0, and pretty much everything else, objects and strings, get set to null. Okay. If you create an object and you pass it data, then it's going to use a parameterized constructor. Okay, so that would be a constructor that is specifically designed to accept data. And I did include a little side note here on null. That is the default value for reference types. And it basically just represents an empty reference. So if you remember with the reference type, the name of the reference points to an area in memory, and that area in memory refers to a completely different area. Okay, so that area that it is referring to would be null. Okay, and so null is what is assigned by default to a reference type. Integer, double, character, those are all value types. They cannot be assigned null. Okay, so only the objects and strings can have a value of null. So the two types of constructors. We have the default constructor that doesn't have any data being passed. And then we have a constructor that does have data being passed, where you have to indicate the data type, and then you have to give the variable a name. And then you can see that you take that variable that's being passed in and you assign it to the class field. Okay, you do that for the second one and the third one. Where you are not receiving any data, then if it's a number, you'd set it to 0. And actually, if it's a string, I would just do it to double quote, which is an empty string. But if it was an object, I might initialize it to null. Okay, but it's kind of up to you what you set for those initialization values. Now, with a constructor, the name of the constructor is the class name. And so here I've got two constructors with the same class name. So this is an example of polymorphism. And the way that C# differentiates them is it looks at the signature, which is the data that is being passed. And that has to be different. And you can tell it is. Okay, so that is how it knows which one to use. Okay, so it is always helpful to see an example with real values. So here is an example of a club class. So the name of the class is club, and you can see I've got 3 members. They're all private. I have a default constructor, and you can see I've set the ID to 0, and I have set first name and last name to empty strings. And then for the constructor that accepts past data, I am bringing in values, and I am assigning those values to my different fields that are in my class. Okay, and then I've got my get methods and I've got my set methods that we looked at earlier. So once I've got my class set up, I can create a class object. And as I mentioned, creating the class object actually creates a variable that is in memory. And you can put values into the different fields. And we've talked about value and reference types. We talked about it in the review, and we're going to talk about it again today because it is really important that you understand the difference. And class objects are reference types, which means they are stored in a part of memory called the heap. Okay, and that is a little different than where value types are stored. Okay, so reference types, if you remember, we'll have an object name, and that's going to refer to a location in memory. And that memory location is going to refer to the spot in memory that actually stores the data. So to create an object, you have your class name, whatever you're going to call the object, you set that equal to new and class name. Now, if I did it like this would call the default constructor. Okay, and here's an example of the club class where I've got club, name of my class. The object is member. New club actually creates my member object, and then it goes through the default constructor and initializes the values of the fields. This next example, I am creating a second club object. Now this one is called member 10. And when I create it, I'm passing it data. So this is using the parameterized constructor. Once you have a class object, you can access public members of the class using the object.memberName notation. For methods, you can use the object name.methodName. And if you did have a public field, it would be object name.fieldName. Okay, and so in our class, we made all of the fields private. So we cannot access them from the main method, but we can access the club methods, okay, because those are public. So this little example, we create a object called member 10, and member 10 is passed data when it's created, so it goes through the parameterized constructor. And then let's say we want to print that information out. So we have to use the object and a dot, and we can't directly access ID or first name or last name. We have to use the get methods. Okay, so it's member10.getID. That will go to that method. And if you remember, that method, the only job it has is to return the ID because the ID is private. Okay, so it will return the ID and it will return it to this location where it can be printed out. Name equals member10 is my object dot get full name. So get full name. Its job is to return the first name concatenated with a space, concatenated with the last name. Where does it return it to? Returns it to this location where it is printed out. Now, what if we do something like this? We create a new object, but we don't pass it any data. So we use the default constructor where it sets things to zeros and null. How do we get data in? We need to call the set methods. So this example, I am calling set ID and I'm passing it a value, calling it set first and set last, and I'm passing strings. So that is how I'm getting the data into the fields that are associated with the member object. Okay, and then to print it out, it's kind of the same thing, although I'm going to pause here because I see a problem. I'll tell you the problem first and I'm going to fix it. So when we write it out, we should be writing out member, right? If we write out member 10, we're going to get Fred Flintstone instead of Wilma. So let me fix this. Okay, that looks better. So if we set Wilma's information, that's what we want to print out. And so we've got the object, which is member, dot get ID, and we got the object dot get full name, and that refers to this one that we just set. And then here is the full program, and you can see in here that it is done right. And if you wanted to copy and paste the program, it should run. So what we just looked at was private fields. And now we're going to take a look at how you handle public fields because they're handled a little bit differently. So with public fields, first of all, you don't need get and set methods because the other program can directly access first name, last name, and ID. Okay, they are not really hidden or protected. So they're public. So basically all we have here for methods, we have a constructor, a default constructor, we have a parameterized constructor, and then we have the get full name method that, formats first and last name. That's really all we need here. Then in our main program, we still create objects the same way. So this technique is using the parameterized constructor, and this one is using the default constructor. Then to access our fields, we don't have to use get and set methods. Okay? Because they're public, we can just do the object, a dot, and then the field. Okay? Object, dot, and field. Okay? So that is how we access those fields, whether we're retrieving them or putting data into them. Okay, so here our object is member 20, and so it's member20.id, and we're setting that to 20. Member20.firstname, and we're setting that to Wilma. Okay, so we've eliminated the need for the get and set because we can access those fields directly. Okay, and it's really only if you want to print out the first and last name that you would even have to call the get full name method. If you want to print out the first name individually and the last name, you do it like this. If you want the formatted one, you would do it like this and call the method. So we looked at an example that had all private. We looked at an example that had all public fields. And so here's an example that has mixed. So you can see I've got ID, name, and type. Those are public, but I set the bools is dangerous as human to private, and I have a list of powers that are also private. So I did go with the naming conventions here. You'll notice that the public ones do not have underscores, but the private ones do. So, how would the default constructor work? Well, it kind of works the same way as before. Okay, so there really isn't anything different. It's still going to initialize those fields. How does the parameterized constructor work? Same way as before. Okay, it's still going to receive data that is passed, and that data is going to be used to initialize those fields. What about the methods? Well, for our private fields, we are going to need get and set methods. We do not need those for the public ones. So for the private fields, you'll see there is get methods and there is set methods. Then we get down to our main program. And so we're prompting them, how many creatures do you want to enter? We're pulling in whatever value they say. We've got a little creature counter so we can keep track of how many we've entered. Set that to 0. And then we create a creature object called myCreature. And that is going to be using the default constructor. So it's going to set everything to, 0, empty strings, false, okay, just like is shown up here. Then we get into a processing loop. So we've got our while loop here. So the while loop starts here with this curly brace, and it ends down here. Okay, so pretty much all of our code is inside that. Let's see if I can zoom out a little bit. A lot of code here. All right. So I've got while creature counter is less than count. Okay, so creature counter, when we first come through, creature counter is 0. Count is whatever they keyed in. So maybe they want to do 4. Okay. We're going to take the counter and make that the ID. Okay, so whatever the counter is, that becomes our ID. Then we tell them to enter the type of creature. Okay, we're using console.readLine to read it in. And remember that reads in a string, which is fine because type is a string. Now, if you remember, type is a public field. So we can just use the object dot and then the field name. And we can store the data directly in there. Then we say, enter the name of the creature. Again, we're using console.readline, so it's a string, and we are storing it in name, which is also a string. Name is a public field, so we just take my creature, which is our object, dot name. And then we get into our private fields. So we are reading in the prompt here for, is the creature dangerous? So they're going to do a yes, a Y for yes, and for no. So we're using read line, and we are converting it to a character because we are storing a character, not a string. Okay. So whatever they type, Y or N, gets stored here. And if they indicated a lowercase or an uppercase y, then we are using the myCreature object to call set danger status, which is a set method. And we're passing it true. So what did set danger status do? It's a private field, okay, is dangerous. So we're running through here and we're passing it true. Okay, so danger is going to have a value of true. Okay, so it takes that value of true and it puts it into is dangerous. The next one is the creature all or part human, Y for yes, N for no. We read it in the same way, using char.parse to convert it into a character, store it in a temporary variable called temp human, and we check it for an upper or lowercase y. Okay, and so if either of those is true, then we call set human status and we pass it true. And this works the same as set danger status. Okay, so if you look, they're pretty identical. Set human status is bringing in a Boolean. Okay, we sent it the value true, so this human variable becomes the value true. We take that variable and set it to is human. And then we get down to powers. Now the powers are stored in a list, and a list is something that we learned last semester. And if you're not familiar with a list, we will be covering it again, so no worries. But here we're saying, does the creature have powers? Yes or no? Same thing where we're reading the character in, we're checking it for upper or lowercase y. And we take the list, tell it that it's a string, and we give it a name, pow for powers. And we indicate it's a new list. And the data type is a string. And for right now, it's empty. That's what these curly braces with nothing mean. And then we have, I'm going to call it a flag, power entered. We set that to empty string. And then we say while power entered doesn't equal quit. Okay. And so we set powered enter to blank. So when we first come in here, well, it doesn't equal quit. So it's going to go through this at least once. Okay. And it says enter their power or quit to end. Okay. So powered entered is whatever string they typed in. If they did enter the word quit, then we're skipping the rest and we're going back up here. That is what continue does. Okay, so should have caught that in the review, but it is important that you know how to use continue and break. So if you're confused about them, please reach out. But basically continue. If you're in a loop, it just says skip all of the instructions below and start back up at the top. So if they did type quit, it's going to double check it here and be done. Okay. And if they didn't type quit, then it's going to add whatever they typed to the list. Okay. And it'll keep adding to the list until they enter quit. Okay. And once they enter quit, then we're done with the loop. And we come down here and we add 1 to the creature counter. Come back up here and check the counter to make sure it's less than the count. And the count was 4. So at this point, the creature counter started at 1, at 0, and now it would be at 1. And it would go through again. Okay, and this is just a sample of how it looks when it runs. And in the book, they do have a program that has a main method, and it also has a point class. And so, you know, the code gets kind of lengthy when you put everything in the program.cs file. So if we look at all of this, this is fairly lengthy. So I can actually create a new project here. And I'll just call it Mythical Creatures Part 2 to be continued. All right, so I'm going to copy this and show you what you can do. All right, so here it's all in one. And I'm just going to run a build to make sure I didn't miss anything when I was doing the copying. All right, so this is rather lengthy. And what I'm going to do is I'm going to create another file, and I'm going to have the exact same namespace. And I am going to take this creature class and put it in that file. So let me go down to add. I'm going to add a class. C# items, class is what I want. And I'm going to call this creature, right? Okay. And you'll notice it does take your project name. That's not the same as the name that I use for my namespace. So I'm going to change that. Okay. And then I don't need this. And I don't need this one. Okay. But everything in between I do need. I'm going to move this chunk code. So I'm just going to press Control and X. That does a cut. Come over here. And I'm going to paste it right there. So now I've got my creature class. It's still in the same namespace. It's just reorganized a little bit. Okay. So that little code with the equal arrow, in fact, this is the exact line that we were looking at. This is called expression bodied method. Okay. And anytime all you're doing is returning something like this, okay, you can omit the curly braces in the word return, and you can just use equal greater than, followed by the value you want returned. Okay? And it does save you a little bit of typing. Okay? And a lot of coders like to do this, so you will see these shortcuts. If you look on the web for C# programs, you will see them. When we get into doing some more complicated applications in other classes, we used a lot of generated code, and you will see this type of thing in the generated code as well. The this keyword. So when we were looking at the example, you may have noticed that this keyword is used. The reason they're using the keyword is because they have private variables and they did not begin them with the underscore. And so in a case like this, where you're pulling in X and Y, that's what you're calling them. If you just said X equals X, then the compiler does not know what the heck you're referring to. So this dot X is referring to the current object, and the current object is dealing with these members. Okay, so this dot X is referring to the member X. And this dot Y is referring to the member Y. Okay, and so they've followed that convention up here as well to differentiate between the X and the Y that are part of the class and the X and the Y that get passed in from the main method and other places. Okay, so down here, you'll see the same thing. This dot X and this dot Y is referring to the fields that are, part of this particular object. Other X, other Y, those are the ones that are getting passed in. Now, if you follow the naming conventions that we have used, okay, then you don't really need to use the keyword this, because if you put the underscore in here, okay, now they become unique, right? So now we can just put the underscore in. And we don't have to worry about the compiler getting confused because they are different. And this is part of the reason that this naming convention exists, is to avoid having to use the keyword this. Now that brings me to static fields. So the main method, not only static fields, but methods and classes too. But the main method is a static method. And we use that from day one. Static field, you already saw an example of how that was used in the textbook authors program. And so another little example here is the transactions. Now, in this example, you'll notice that transactions is not static. And so when it's not static, it really is not keeping track of the transactions correctly. Let me open up kind of my little junk file here. All right, so if I run this, you'll immediately see what the problem is. Okay, so I've got transactions equal 1, name is Jones. Let's see, we'll do Flintstone. Transaction equals 1, name is Flintstones. Rubble. Transaction equals 1. Okay, so that is the problem. Okay, it's not accumulating my transactions. And that is why people use static fields. With a static field, every single object shares one field. So you can increase the value. That value is going to stay there. Okay, it will remain increased. So we're going to take a look at this same exact example, but now we are making transactions static. Okay, and then you'll be able to see the results. So, whoop, copy that. Copy this one, hopefully. And let's run this one. Okay, so we'll kind of do the same thing. So now it's 1. Should be 2 this time. Yep. And then this one should be 3. Okay, and that is why people use static fields. Now we were just looking at a private static field. Well, what if we made it public? Well, if we make it public, we do not need the get and the set method, and we can actually access it from our main method using the class name, a dot, and then our field. And we can only do that because it is public. So the net effect here is going to be the same, but we just don't have to have all the class methods that we did before. Okay, so I would expect the same type of output that I had before. Okay, no difference in the output. It's just a little different way of creating your code. Okay, and again, we're increasing the value in the main method because it's public. And we can just use the class name, a dot, and then our field. Static methods we have been using since day one because the main method is a static method. And with the static method, you do not need a class object to call the method. Okay, so you can call the method without a class object. So the access modifier is static. Okay, and then the rest of the method is the same as the other ones. You have to have a return data type, you have to have a name, and then you've got your parameters that you are passing. So to use a static method, you basically just call the method. Okay, whereas if you're using a private method, you have to use the object, a dot, and the name of the method. And here we don't require an object because it is a static method. So this example showed a couple of static methods, find max and find min and cube, and they were all in the same class. Okay, they were all in this program class. So we have our main method, okay, and right below that, we have find max. Right below that, we have find min. So they're all in the same class. Well, what happens if I have a static method in a different class. So what happens if it's something like mythical creatures, right? Where I've got my program class and I've got my creature class. What if I put a static method over here in the creature class? How would I call it? If you do something like that, then you have to tell C# what class it is in. So you have to use the class name, a dot, and the method name. You still do not need an object, okay? But if you have multiple classes in your namespace, you're going to have to tell it what class the static method is in. Okay, so here's a similar example to the one that we just looked at with find max and find min and q. The difference is I put those static methods in a class called calculations. So we have a class called program and we have a class called calculations. So down in the main method, if I want to call find max and find min, I have to prefix them with calculations because that's the name of the class that they are in now. So what the heck are static constructors? Well, the way we initialized transactions before was we just set a default of 0 up here. But you can create a static constructor. And if you do that, then the only values it can initialize are ones that are static. Okay, so it'll still have the same name as the class. The only fields that will be in it are the ones that are defined as static. You can see it says static here. Okay, and so that is how you would initialize a static field if you had a static constructor. All of the other fields would go in the default constructor or the constructor that accepts parameterized data. So static classes are classes that cannot be instantiated by their users. So that means you cannot use the keyword new to create an object. So in a static class, all of your fields and all of your methods have to be static. So here is an example of a class that is public. So this is not a static class. It's called college student. And then down here, we have a static class called student. So we got college student and we have student. So student is static. And that means that the fields are static and the methods are static. Okay, and there's a difference then in how you use a static class versus a non-static. So if you're going to use any of the fields in the static class, it is simply the class name dot and then the field. Okay, because you cannot create an object from a static class, you would not say student whatever equals new student. You can't do that. Okay, so you would just simply say student.id, student.name, okay, and use them directly. For a non-static class, well, you do it as normal, right? You've got your object here equal new, and then you've got your class. Okay, these were public fields, which is why we can take the object dot the field to fill it in. Okay, and so that's just the difference.